This is the Nicholas Catchlove Lecture at the Charles Perkins Center. I'm Steve Simpson. I'm the Academic Director of the Charles Perkins Center. We have had a hiatus of 2 years thanks to COVID, when we haven't been able to hold the Catchlove Lecture, certainly not in person, and that makes this one even more special. I'd like to begin, as always, by paying my respects to the traditional owners of the land upon which the Charles Perkins Center is built, the Gallagher people of the Eora Nation, their elders past, present, and emerging, and also to recognize Charlie Perkins, Dr. Charles Perkins, our namesake and role model at the Charles Perkins Center. I'd also like to welcome to the audience Barry Catchlove, Penny Catchlove, and Louise Sylvan. This lecture is named in honor of Barry's son. And today we have a real treat. We have with us at the Charles Perkins Center Professor Doug Seals, who's from the University of Colorado. He's here on a sabbatical visit, heading off next to New Zealand with his wife Cindy. He's been working with our scientists, particularly Professor Luigi Fontana, whom you'll meet in a little bit in the Q&A discussion, the panel discussion that follows Doug's lecture. Now, Doug is Distinguished Professor of Integrative Physiology and Medicine at the University of Colorado, and he is really the world leader in healthy cardiovascular aging. And being in receipt of an aging heart, it's of particular interest to me, and I'm sure it is to all of us here. Doug has a particular interest in establishing evidence-based strategies for promoting healthy cardiovascular aging, and this evening he's going to consider contemporary views of biomedical aging in humans, including the new focus on what we've come to call health span. That is the proportion of your lifespan that you live in good health. The hope being that you live as long of your allotted years in good health as possible. And how do we achieve that? So with that, Doug, I'd like to welcome you to the stage. Thereafter, we'll have, as I said, a panel discussion. And after that, I'd welcome you all to join us for a reception outside this room. But for now, please welcome Doug Seals. Thank you.
Thank you very much. It's really a privilege to be here this evening presenting the Nicholas Catchlove Lecture. I want to start with my own round of thanks, of course, to the Catchlove family for their generous support of this lecture, for Steve Simpson for sponsoring my visit here. Thank you, Steve. Luigi Fontana, Professor Fontana, and his laboratory, I see several of the members of the lab here, have been wonderful scientific hosts, and we've been sharing research ideas the last 2 weeks, and I'm very grateful for the great hosts that they've been. And then last but not least, the wonderful staff at the center who have given us so much administrative support, so much advice, and I'm very grateful for that. We do, as Steve mentioned, want to talk tonight about healthy cardiovascular aging, and particularly strategies that you can consider to attain that important goal. As Steve also mentioned, if we start with the big picture, we start with the concept of health span, and this is sort of the new hot concept in biomedical aging research. Previously, there's been a lot of emphasis on extending lifespan, but as Steve mentioned, now there's much more focus on making sure that we live that lifespan as much as possible in a period without serious chronic diseases, with good physiological function, and at a high quality of life. And that's this health span period that's shown here in green. At some point, and that point in terms of age differs among individuals, we will regress from that period of health span and begin to develop chronic disorders, lose a little bit of our physiological function as we continue to age, and at some point may even undergo a reduction in the quality of life. So the holy grail of biomedical health span related research again is shown here, that we're able to go from a health span profile, at least at the population level, considering the whole population, that may look now something like this in Australia, in the United States, and be able to extend the period of health span while also compressing the period of illness and dysfunction to the very end of our natural lives. This is really the goal of biomedical research in this area. What I want to talk to you tonight about is the important role that keeping our cardiovascular systems healthy throughout the lifespan will play in our ability to be able to achieve this transition to a more ideal health span profile. And in doing so, it'll be clear that unhealthy cardiovascular aging represents a major barrier for us to be able to attain a more optimal health span profile. Does that make sense so far? Okay, I see enough nods. I'm going forward. Let me try to begin to make a case for the importance of healthy cardiovascular aging. Now, these are results from the population in the US, but it's the same for Australia. And we're looking at the major causes of death, the number of deaths shown here, by various contributors to mortality. And you can see here that cardiovascular diseases contribute more to population mortality in developed and developing nations than any other cause. The closest one would be cancer to cardiovascular diseases. And this distribution, this high number of cardiovascular deaths, is unfairly distributed to midlife and older adults. So here what I'm showing is the prevalence of all cardiovascular diseases in relation to age. So percent of the population with cardiovascular disease. And here we have increasing decades of age left to right. You'll see that in young adults, cardiovascular disease is rare. But once we reach midlife, there's a progressive increase in cardiovascular diseases. And this means that cardiovascular diseases really, in general, are diseases of aging. That's an important early point. If we now look at projected increases in the number of older adults in the future, and here we have adults in millions over 65, very few in the US, maybe 4 million adults in the 1900s, early 1900s, that reached that age. But we've seen a progressive increase, and the dotted lines here represent what we project in the future. So continued marked linear increases in the number of older adults. So let's pause here and just summarize and integrate what I've just said. We have a lethal, highly lethal set of diseases, cardiovascular diseases. They increase with aging. Very tight association with advancing age. And there will be many millions more of older adults in the future. So now if we want to project future increases in cardiovascular disease, the curve looks something like this. This is not sustainable for any society, developed or developing. The government insurance programs aren't going to be able to support that kind of increase. Our healthcare facilities and personnel and equipment will not be able to support it. And patients, of course, themselves and their family caregivers. This is not sustainable from that perspective. So we must figure out some way to what scientists would call flatten the curve. We must be able to reduce substantially the number of additional people that are going to be developing these diseases in the future. The challenge for scientists like us are, where do we look for answers? What aspects of the cardiovascular system do we target? And that's really been one of the major burdens of moving science along in this area. In our laboratory, we've kept it simple. For the last 25 years, we've been conducting research in this area, and we ask the simple question, what is it about aging that increases our risk of cardiovascular disease? What events are occurring in the middle that stimulate these diseases and their development? You might naturally think first of the heart. When people think of the cardiovascular system, they tend to think of the heart first, and that's a reasonable hypothesis. The heart does undergo some changes with advancing age, and some of those changes are health adverse, true. But it turns out that essentially all of the changes that occur in the heart with advancing age are due to other changes in the cardiovascular system. They're not primary to the cardiac function. One of those changes that drives the age-related increase in cardiovascular disease is increases in systolic blood pressure. So let me just review. When you go into your doctor's office and have your blood pressure taken, you're aware that there are two values that you get. Systolic blood pressure is the top value in the ratio. The second, the lower ratio value, is diastolic blood pressure. Now, we're particularly concerned about systolic blood pressure and how it changes with age. These are data from a large population study in the US, but again, the same results would be observed in Australia. And on the left side are data in men, on the right side, data in women. And on this axis here is just systolic blood pressure from low here to higher levels. And what you can see is diastolic blood pressure increases very modestly in the population with advancing age, levels off about the age 50, and actually declines at older ages. That's the profile of diastolic blood pressure. But in marked contrast, note the change in systolic blood pressure from young adulthood. There's a progressive increase. And these different colored lines are simply different ethnic and racial groups, so it's observed in any demographic. Now, the concern here is based on the fact that we know from population, or as we describe it, epidemiological data, that ideal systolic blood pressure is less than 120 millimeters of mercury, or you can just think points. Here's a line at 120 here for men and here for women. And you can see is after we leave young adulthood, as a population at least, we spend most of our adult lives over, and in some cases well over, that ideal level. And any increase in systolic blood pressure above this gray line is linearly correlated with increases in cardiovascular disease risk. So when we get out here in late midlife and older adulthood, you can see the marked increases in systolic blood pressure and how they're likely contributing to increased risk of cardiovascular disease. So this is one of those targets. The other event that drives increased risk of cardiovascular disease with aging are dysfunction of the arteries. And you might recall, if you think about your biology studies, maybe many years ago, that the arteries are the blood vessels that accept the blood from the heart each time it contracts and then distributes that oxygenated, nutrient-rich blood to all the different tissues and cells and organs of the body. So it's from the heart out. Those are your arteries. The veins bring the blood back to the heart, okay? And we're particularly interested in impairments in artery function and artery disease as we age, in contributing to the increased risk of cardiovascular diseases. Now, there are two major changes to your arteries that I want to tell you about before we move forward. One is the stiffening of some of the arteries in your body. And the arteries that stiffen with age are specifically the aorta, and that's the big artery that accepts blood when it's pumped out of the heart, and the carotid arteries, which also have to accept that blood and deliver some of it to the brain. Those are called the large elastic arteries, and the term elastic is in there because that's what they need to be. They need to be elastic, they need to be highly distensible to do their work. So when the blood is pumped out of the heart, those arteries, as I mentioned, have to accept the blood. So they must distend in order to do that. And then as the heart relaxes and rests, then the artery recoils. And by doing so, creates the kinetic energy necessary to drive blood to all the tissues of the body. You must have elastic arteries to do this properly. And when we're young, that's exactly what we have. Very robust expansion and recoil. That's a healthy cardiovascular artery. But as we age, our arteries stiffen, and the expansion and the recoil becomes more and more impaired. And this turns out causes a whole host of serious pathological effects. And I'll just mention two because of time here. One, this stiffening of the arteries is the primary reason why our systolic blood pressure increases with age, which we just talked about. Secondly, and this is lesser known, is that when you create stiff arteries, the aorta and the carotid arteries, that changes what we call the pulsatility of how blood flows throughout the body when the arteries deliver that blood. We go as young adults from having a nice low pulsatile blood flow pattern to increasingly more pulsatile as we go through the aging process. And this high pulsatility that we see, particularly at older ages, damages the small, delicate arteries that actually deliver the blood to the brain, to the kidneys, to the eyes, and to the heart in particular. Those organs are very sensitive to this high pulsatile flow. And their small arteries that deliver that blood flow are damaged. And not enough oxygenated, nutrient-rich blood comes to these organs. And these organs are damaged as we undergo the aging process. The other type of artery change that occurs with advancing age is something called endothelial dysfunction. Well, that's kind of a technical term, but it's referring to one of the three layers of our arteries. It's the inner lining of the artery, the endothelial lining. This is a single cell lining. It's very thin. But all of these cells, it turns out, we've just learned this in the last 20 years or so, act like small endocrine organs, producing a variety of biologically important molecules that then feed back and influence the health of the entire artery. And the most important molecule, you could argue, that's produced of hundreds of these molecules is the gaseous molecule called nitric oxide. So just remember that for a moment. Now, nitric oxide is protective. It protects our arteries from dysfunction and disease. Unfortunately, with advancing age, nitric oxide production from these endothelial cells decreases, and we lose some of that inherent protective effect. This then increases our risk of a number of pathophysiological processes in arteries. Our risk of atherosclerosis, hypertension, and stroke, to name a few, increase because of this reduction in nitric oxide availability. Now, we could rightly ask at this point, and perhaps you are, as we would when we see this car and the need for that car on such a small island, why? Why do our arteries age? That's an important question. And it turns out that there are two primary biological reasons, or as scientists call them, mechanisms of action. One is, and you're familiar with this term, oxidative stress. Oxidative stress represents an excessive number of reactive oxygen species, or you may have heard the term free radicals. And those free radicals damage other molecules in other tissues, including in your arteries as you undergo the aging process. Now, the other process that occurs in arteries at the same time is inflammation, and you're also familiar with this term. It's noted by an increase in the number of inflammatory molecules in a tissue, again, in this case, the arteries. And the important thing about oxidative stress and inflammation is they're co-conspirators in causing adverse arterial aging. They stimulate each other, and they create essentially a vicious cycle in the cells of your tissues, including the arteries. And these changes cause changes to the wall of the arteries, the composition of the wall of the arteries, making them more stiff, and also that decrease in nitric oxide level that we just talked about. And that leads to increases in systolic blood pressure, arterial dysfunction, and again, an increase in cardiovascular disease risk. So these are the primary mechanisms at work as our arteries age. Now, the last slide in this introductory section is shown here because before we move on and start talking about what we might be able to do about all this, I want to impress upon you the broader biomedical impact of our discussion this evening. What we've been talking about, to review, is that aging causes increases in systolic blood pressure and artery dysfunction, which leads to an increase in the risk of cardiovascular diseases, 3 of which are shown here. Everybody's with me on that, right? But what you may not appreciate is evidence has come out in the last 10 years or so that these early events also cause a number of other major, highly common age-related disorders. And those include, but are not limited to, chronic kidney disease, cognitive impairment, Alzheimer's disease and related dementias, metabolic disorders, and a number of other age-related events. And we are particularly concerned about recent data suggesting that up to 50% of the risk of Alzheimer's disease and related dementias may be due to this sequence of events. And as a result now, in biomedical aging research, there's a lot of focus on the effects of systolic blood pressure and artery dysfunction on age-related diseases and syndromes. Okay, you've been very patient. What can we do about this? Well, there's a lot that we can do, actually. As I think about this is what I suggest we consider as an overall paradigm. From left to right in the upper part is what we've been talking about for the last several minutes: aging causing cardiovascular dysfunction and risk of disease. But what I've added here in this box is the concept of strategies that might be able to disrupt this sequence of events. And I've labeled 2 categories of strategies: healthy lifestyle strategies and pharmacological strategies. And the approach here is to consider these strategies in 2 contexts. One context is shown by this arm here, and you see the label primary prevention. What does that mean, primary prevention? Well, in this context, it means that these strategies may help to prevent the effects of aging in the first place in causing these changes to the cardiovascular system that we're worried about. Secondly, these strategies may exert secondary prevention effects. What does that mean? That means in those of us who are of an age, for example, that have some increase in systolic blood pressure, some artery dysfunction, an effective strategy would slow, delay, or prevent the transition from this point to the development of clinically diagnosed disease and disorders. Hopefully, a robust strategy would exert both primary prevention and secondary prevention effects, and that's what we're looking for. So what do we know about healthy lifestyle strategies and pharmacological strategies from a standpoint of scientific research? Well, you won't be surprised by this, but the strongest amount of data support healthy lifestyle-based strategies to disrupt this sequence of events, particularly those involving regular physical activity and eating a healthy diet. Let's talk about that just for a while before we move on to other strategies. If you pressed me and you asked me, I want one recommendation for keeping my cardiovascular system healthy with advancing age, I would say, based on the research that we have, it would be regular exercise, regular physical activity. That is the most evidence-based strategy. So in that sense, exercise is indeed very powerful medicine for keeping that cardiovascular system healthy as we undergo the aging process. All kinds of exercise have some benefits on cardiovascular function, but in particular, the evidence supports a strong effect of aerobic exercise, including walking, jogging, all of the types of aerobic exercise shown here and other forms of aerobic exercise. Regular aerobic exercise prevents the development of cardiac dysfunction. That increase in systolic blood pressure is attenuated, and impaired function of arteries is prevented, both the arterial stiffening that we talked about and the development of endothelial dysfunction. And as a consequence, it also prevents these end products of this sequence of events. So all of the clinical disorders that have been associated with poor cardiovascular aging. We also know quite a bit about how exercise exerts those beneficial effects. And the key mechanisms are those that we talked about as being central to stimulating adverse arterial aging and increases in blood pressure in the first place. And that's inflammation and oxidative stress. There's very strong support that exercise prevents, which is what this bracket shows here, inflammation and oxidative stress from developing in our arteries as we undergo the aging process. So it blocks the development of that vicious cycle, and as a consequence, the downstream effects it has. Okay, so exercise, very strongly evidence-based for preventing cardiovascular aging. Food also, at least the right kinds of food and the right amounts of food, is very powerful medicine for promoting healthy cardiovascular aging. Let's talk about that for a few minutes. There are two different expressions of dietary influence as we think about its effect on the cardiovascular system as we age. One is simply the amount of food that we take in, the amount of food that we consume each day or each week, independent of the composition of that food. And that's what this slide is depicting here. How will different levels of food intake or calorie intake influence cardiovascular aging? This is tough to study in people because we live a relatively long time, longer in some cases than the investigators who are trying to study the effects. So we cannot control diet in someone from early adulthood and follow them through life and study them. That's obvious. So a lot of investigators, our laboratory included, have attempted to gain initial insight into the influence of food intake by studying shorter-lived models. And Mice and rat models have been used extensively, including mice who live only on average about 2 years. So we can study them from young adulthood all the way to the end of life quite easily. And these are more concept studies. Let me summarize what we've found from studying different levels of food intake in mice. So this is artery function. The higher you go up, the higher the bar is, the better the function. If we take mice and study them from young adulthood on, as young adults, just like you'd expect, they have very robust, healthy artery function. No surprise there. If we allow them to eat all of the mouse chow, this is standard healthy mouse chow, but we let them eat whatever they want, and we study them again at old age, we see a decrease in artery health. Again, not surprising, exactly what we would expect, okay? Now, let's change the experiment. Let's take the same young mice, but instead of letting them eat whatever they want throughout their lifespan, we reduce the amount of food by about 30 to 40% below what they would eat naturally if you just allowed them to eat as much as they wanted, okay? When we study them now in old age, instead of this response, this is what we see. We see completely preserved artery function in old mice who have had food restriction for their adult life. Same level as what we see in young mice. So we've essentially preserved arterial health during that period. And what's even more interesting is if we allow mice from young adulthood till about middle age or even late middle age to eat as much as they want, but then we slowly start reducing the amount of food that they take in, very carefully, very gradually, and then we study them at old age, we see the same preservation of artery function. So the point of these studies in mice is that they provide what we call in the laboratory proof of concept evidence that food restriction may have a very powerful beneficial effect on how our cardiovascular system ages. Of course, mice are mice, and they're only mice. We want to know if this is relevant to people, right? So we can't study humans throughout the lifespan, as I just mentioned, but we can study food restriction in a more narrow time frame. And we and other laboratories have studied the effect of restricting food intake in midlife and older adults. We've started with a group of middle-aged and older adults who have poor artery function to begin with. And then we put them on a food-restricted diet, 12 weeks in the case of this particular study, at 33% less calories per day than what they normally eat. And after 3 months, this leads to about a 10% reduction in body weight. So that's the paradigm, okay? After the end of this 3 months, we study them again. Their systolic blood pressure has decreased at least 10 millimeters of mercury, at least 10 points, which is more than you get with initial phase of antihypertensive drug treatment. This is a very robust reduction in systolic blood pressure. And if we study their artery function, we see about 30% improvements in reducing arterial stiffness and increasing their endothelial function. So again, we don't have the same ability to study mice and people, but what we have studied is consistent for a beneficial effect of modest food reduction. Okay. The problem with chronic dietary restriction, chronic reductions in food intake, is, as you know, adherence is challenging. It's a tough thing to do day after day. And this has stimulated a lot of increase in interest in intermittent fasting. This term intermittent fasting has been used to describe a number of approaches to reducing food intake, but not every day. And here are 3 popular press books that I'm just using as ways to illustrate the different approaches. On the far left here, we have alternate day fasting and feeding. So eating normally one day and reducing your calories the next day. In the middle here is the 5-2 diet, reducing your caloric intake 2 days a week, eating your normal amount of calories 5 days a week. And over here on the right is time-restricted feeding, associated with, in this book's case, the 8-hour diet. And time-restricted feeding allows you to eat whatever you want to eat in terms of the volume of food, the number of calories, but you must do it within a restricted time of day. In the case of the book, it's suggesting 8 hours. And there have been studies that have been performed from probably around 6 hours a day to higher than that. What we know from early studies in this area is that there's really no clear evidence that there's benefits from intermittent fasting as we have found in chronic caloric restriction. But we still need more data. We're still very early on. Only a few well-controlled studies have been performed so far. But we're lucky in this audience tonight because in the panel discussion, we have Professor Luigi Fontana, who is probably the world's expert in intermittent fasting in humans. So we'll look to Luigi for his comments later. The other kind of dietary influence isn't how much food we eat, it's the composition of the food, right? That's the other potential influence. And we actually know a lot about the relation between diet composition and how healthy our cardiovascular system ages. This is a nice art graphic table, and on the left corner is just different diets or dietary factors, different types of foods. In the middle, what happens when we go on a diet emphasizing that dietary element. And on the right is just the amount of evidence, research evidence we have supporting those diets. And so there are a number of healthy dietary patterns, as they're called. Mediterranean diet, vegetarian diets are obviously something you know about. Higher fruit, vegetable intake. There are a lot of healthy diets that we have a lot of evidence for that increase endothelial function and suppress the stiffening of arteries with advancing age. Good data on those. And we could go through this entire list if we had a lot longer to talk about and talk about each factor. We can do that in the panel discussion. But one of the factors that I want to emphasize to you before we leave this point is dietary sodium intake. Now, you've heard a lot about, yeah, I need to keep my sodium intake down and so on and so forth. You hear that, your doctor may tell you that, you may read about that, but what actually is the impact on how your cardiovascular system is aging? Let me just show you real quick. Most countries, healthcare organizations, have dietary guidelines for how much sodium to take in per day. And this is generally the range, 1,500 to about 2,300 milligrams per day. You won't be surprised that, and I'll use the US so that I'm not picking on the Australian population, the average dietary intake of sodium in the US is much higher than this. That is not a surprise, I realize. But the question we asked based on this is, what about if we lowered the level of sodium intake and got it somewhere between these guidelines in midlife and older adults? Could we improve their cardiovascular health? So we've done 3 different clinical trials and shown the same thing in each one. When we bring midlife women and men into the clinical research center and our bionutritionist works with us to reduce their sodium somewhere in this range and keep it there for only 3 to 4 weeks, the changes are remarkable. We've seen consistently 10 to 15 millimeter mercury reductions in systolic blood pressure, and also, depending on which study we refer to, somewhere between 25 and 75% improvements in artery function, reductions in stiffness, increases in endothelial health. So again, this is remarkable. a much further, much greater effect than we would see with antihypertensive drug therapy. So be mindful of sodium intake because it has a big effect on how your cardiovascular system ages. Well, I think we've solved the whole problem with unhealthy cardiovascular aging. We're just going to all engage in these healthy lifestyle practices, and if it's okay with Steve, we'll just break early and go to the reception. No, it's not quite that easy, is it? It turns out that less than 50%, in some cases well less than 50%, of midlife and older adults in developed and developing countries follow medical guidelines for eating a healthy diet and how much physical activity they would receive. That's probably not a big surprise for you. There are others in the population, for example, those that are disabled, that have a difficult time meeting exercise guidelines. And there are people often in the lower socioeconomic status demographics that don't have the money to buy healthy food. They don't have access to healthy food. They don't have the time to prepare healthy food. And this leaves clinicians, including those in the center here, seeing patients that have high blood pressure, overweight, etc., diabetes, asking, what else do you have for me? Because what you're suggesting, granted, it's impressive, but it won't work for the patients in my clinic. I need something else. And so these demands have led to a lot of interest in alternative or complementary approaches that have promised to be associated with higher levels of adherence, higher levels of compliance with that treatment or preventive strategy. So there's been a lot of interest in what you might call healthy lifestyle mimicking strategies. And as I define it here, these are strategies that are intended to mimic the effects of regular physical activity and eating a healthy diet without actually being able to achieve those goals. And you can understand why there's been interest in this area. One part of healthy lifestyle mimicking strategies are dietary supplements. And I've chosen to talk about this and not other aspects because this is something we all hear about. This is something we're all exposed to. We go down into the grocery or the pharmacy aisle and we see aisles and aisles of different kinds of dietary supplements. We hear commercials, we read printed ads, and they're promising health span extending benefits of these dietary supplements. And so I'm just going to take a moment and share a couple of points of view about this. One type of supplement that is being really pushed, one category, might be called nutraceuticals. Now, that's a strange term. It's the combination of natural and pharmaceuticals kind of put together. And these are food supplements with naturally occurring ingredients that are, and this is important, purported to have health benefits outside of their basic composition. There have been hundreds of these types of nutraceuticals that have been studied. Some have shown more promise than others. I've shown a few here that have been studied a lot. Beetroot juice is a supplement that's been studied a lot because it increases dietary nitrate intake, which can be translated biochemically to increases in nitric oxide, that molecule that we want to keep up. Curcumin, it's the bioactive ingredient that gives curry spice its yellow color, has very powerful anti-inflammatory and antioxidant effects. That's been studied. You've heard about resveratrol, the bioactive ingredient in red wine that is thought to mimic the effects of dietary fasting. And these and several other nutraceuticals have been able to show some evidence, some promise of effectiveness in improving cardiovascular health in midlife and older adults. But the results are inconsistent, and we need much more data. And I want to make one final point before we leave the supplements is caution. I want to emphasize caution, because of these hundreds, perhaps thousands of dietary supplements, and with people pushing them in the media and on advertisements and so on and so forth, promising the fountain of youth, very few of these supplements have even been studied, much less be considered evidence-based, show positive effects. So if you're interested in exploring consuming some dietary supplement, read about it, do your homework, talk to your physician before you start to take it. Okay, that would be my advice. All right, I'm going to wrap things up here in the next few minutes, but I thought you might want to know what's new, what's in our pipeline of novel strategies that we're exploring. And I'll only give 2 examples, and we can talk about those and others later if you'd like. So here are 2 examples. The first one is a form of physical training. And this form of physical training is intended to address some of these major barriers that people say who don't exercise as to why they are not physically active. And those include access to facilities, the costs, transportation, and particularly time. This is arguably the #1 barrier when you ask people why they don't exercise. I simply don't have the time. I can't meet those guidelines. We've talked about aerobic exercise, and it's a very, very powerful anti-aging strategy in terms of the cardiovascular system. It's a very strong, healthy lifestyle strategy, and it prevents these adverse cardiovascular changes. The problem is the recommended guidelines for weekly aerobic exercise, 150 minutes. Now, if you exercise every day, if you walk briskly for 40 minutes, this is not resonating with you. But it's resonating with most of the population. And they say, I do not have the time. I do not have 150 minutes a week. Maybe they do, maybe they don't. But in their mind, they don't have the time. So we've been exploring a novel strategy that involves more of a time-efficient approach to see if that will also induce some of these favorable cardiovascular changes. And it involves a small handheld device, the opening of which can be adjusted, and you breathe through this device, and you can set it at different levels of resistance to inspiration, or the inhalation phase of breathing. And the physical training type that this involves is called inspiratory muscle strength training. And it's because we have to use our inspiratory muscles, including our diaphragm, the main inspiratory muscle. That has to work hard to be able to breathe in when the resistance is changed, when it's harder to breathe in. You can perform inspiratory muscle strength training either at a high resistance, so really difficult, challenging to breathe in, or at a lower resistance. And we've chosen to study this with high resistance, so more difficult to breathe in. And the idea is, can we use a higher resistance, but ask people to take fewer breaths, thus shortening the period of required exercise per day. So with high resistance inspiratory muscle strength training, we ask subjects only to take 30 of these breaths per day. And that takes about 5 minutes compared to the 30 minutes or whatever that it would require for aerobic exercise. Do this about 5 times a week, just like with aerobic exercise. So it's an attempt to establish evidence for a time-efficient form of exercise. Now, these are data from 5 different small trials that have been conducted in the last few years by our laboratory, the one in the middle here with the green check mark, and our colleagues at the University of Arizona, led by Professor Fiona Bailey, who's also an Australian, by the way. And here's systolic blood pressure, and in the black dots are what the blood pressure is of the group in question, young adults in these 2 studies, midlife and older healthy adults in our study, and midlife and older adults with obstructive sleep apnea, a breathing disorder, in these 2 studies over here performed by Dr. Bailey's lab. And in each case, you can see after a few weeks of inspiratory muscle strength training using this high resistance 5 minutes a day, we've decreased systolic blood pressure by an average across the 5 studies of 10 millimeters of mercury. 5 minutes a day, 5 days a week. So there's something very powerful about this particular type of breathing that is showing promising results. In our study that we recently published, we also measured the effect on vascular function, and we saw a marked improvement in that endothelial function, endothelial health, from before inspiratory muscle strength training to after. This is just a placebo kind of training. It had no effect. So it's very, very promising, and I want to just leave this particular example with past, future, and where we're going with this. So we've performed an initial pilot study in people, very, very encouraging results. We've used those data to get a large grant from the U.S. National Institutes of Health, and we're now conducting a larger clinical trial, and we're doing 12 weeks of inspiratory muscle strength training rather than 6, because at the end of 6, systolic blood pressure is continuing to go down. So we think it'll go down even further. And then at the same time, looking toward the future, we're developing a telemedicine app. And what we want to do is move this research forward using this app so that clinicians, like those here at the center, can consider using this form of training to lower blood pressure in their patients without using drugs. And we also want to be able to translate this form of physical training to the community. So you don't have to be in the clinic seeing your doctor. If you want to lower your blood pressure as a community-dwelling adult, you can purchase one of these devices. They're affordable. And you will have an app that will allow you to perform this type of physical training on your own. Where we've been, where we're at, where we're going. Stay tuned. And the very last example, this is another thing that we're very, very positive about. It's very promising, that's in the queue, is something called passive heat therapy. Now, the concept of passive heat therapy is that we're going to try to increase internal body temperature by 1 to 1.5 degrees centigrade. Passive means not through exercise, not through exertion, just sitting at rest. And we're going to hold that increase of 1 to 1.5 degrees centigrade core temperature for 30 to 60 minutes. And we're going to do that maybe 3 times a week. Now, how did we get this idea? Well, the first clues actually came from population studies in Finland. And what these studies looked at was the frequency of sauna bathing. And it turns out, if you used a sauna multiple times a week, 6, 7 days a week, versus 1 or no days a week, the difference that they found was really impressive. 3 different papers, the first one showing about a 50% decrease in fatal cardiovascular events in those that use saunas every day versus only 1 or 2 days or no days a week. Second study, the development of hypertension in the future was decreased about 50% in those that use the sauna more frequently. And the paper that has had the biggest impact is one that recently came out showing that Alzheimer's disease and related dementias were reduced by 65% in people that use saunas frequently versus those who do not. In this case, it was Finnish men. So, what does that tell us? Well, it suggests that cardiovascular-related diseases are really suppressed by frequent use of saunas and that increase in body temperature that accompanies it. But is that associated with improvements in cardiovascular health? Perhaps the people that use the saunas all the time are the most wealthy people. They have high income, they're highly educated, they see their doctor more, they're guideline followers, they keep a normal body weight, et cetera, et cetera. Maybe it has nothing to do with increasing your body temperature. So now the studies have had to move from the population level down to the clinical research lab. And that's where laboratories like us are now investigating this. And we've switched from sauna bathing to being able to study something that we can do more easily, and that's sitting in a hot tub. That's our mode for increasing internal body temperature 1 degree to 1.5 degrees. This is the paradigm. This is how we do a clinical trial on passive heat therapy. We take midlife and older adults, and we randomly assign them to either a heat therapy condition or a thermoneutral control. What does that mean? Well, if they're randomly assigned to heat therapy, they sit in a hot tub with a water temperature of about 40 degrees centigrade, and we get their body temperature up from 37 degrees to about 38.5 degrees. That's our active treatment condition. And the thermoneutral control is sitting in a hot tub, so they're still immersed, everything's the same, except the water temperature. The water temperature is comfortable to sit in, it's like a warm bath, but it doesn't increase their internal body temperature. And then we really instrument them because we want to make sure they're safe, and we want to make sure that their body temperature is increasing, and we're holding it there for that 45 minutes 3 times a week. Okay, everybody with me? Okay. So here's what we found from a just completed pilot study. Heat therapy, this is about 10 to 12 weeks of heat therapy, 3 times a week, sitting in those hot tubs, reduces oxidative stress, increases nitric oxide bioavailability, those mechanisms that we talked about, improved endothelial function, increased arterial stiffness, and reduced systolic blood pressure by 10 to 12 millimeters of mercury. So again, using these data, and by the way, it was, and this is important, it was very safe and well tolerated. But using the data from this pilot study now, here's where we're at. The pilot study has been finished, very promising results. We used those results to get a grant from our National Institutes of Health, and now we're conducting a larger clinical trial. So we want to be able to confirm that these benefits are real and confirm them in a larger group of subjects, which gives us more confidence. And then again, just like with inspiratory muscle strength training, in the future, what we want to do is be able to, what we call, translate these observations and the use of passive heat therapy to a larger trial in patients, so that that might be another option for physicians, as those in the center here, to offer their patients in the future, and also be able to create an experimental basis, an evidence-based strategy that could be considered by community-dwelling adults. Give them a protocol and an approach to be able to do this on their own and do it safely. Stay tuned. Okay, we're going to summarize here, and I'm going to keep it really simple, just like the professor here on the blackboard, okay? The exciting news from this conversation tonight is that we now know that we have the means to slow, delay, minimize, even prevent this potentially lethal sequence of events where aging causes changes to your cardiovascular system that leads to cardiovascular dysfunction, disease, and disability. We know we can do this. You'll not be surprised to understand and appreciate that the foundation of healthy cardiovascular aging lies in regular physical activity and eating a healthy diet. Not very exciting, but this is the foundation, and that's what investigators like Professor Fontana are studying here at the center. And if we summarize everything we talked about, and we focus on healthy cardiovascular aging here, right in the middle, and in the circle, we see in the dark gray a portion of the circle called old friends. These are evidence-based strategies, strategies that we know will promote healthy cardiovascular aging based on scientific research, based on data. And what we've said is aerobic exercise, chronic caloric restriction, healthy dietary patterns and foods, healthy electrolytes like keeping our sodium intake low, all are old friends that we should embrace to promote healthy cardiovascular aging. On the right side of the circle are new frontiers in the light gray. And these include the possibility that healthy lifestyle-inspired natural compounds might be able to, at least in some cases, contribute to healthy cardiovascular aging. More research is needed. The possibility of inspiratory muscle strength training and passive heat therapy promoting cardiovascular health as we age. We need more studies, as we mentioned, on intermittent fasting, and again, Professor Fontana can comment on that. And I didn't talk about tonight, but another intriguing area that is starting to enter the radar screen of biomedical research is whether gut microbiome targeted strategies using prebiotics, probiotics, or other types of compounds might also have a chance to improve cardiovascular health during the lifespan. So I'm going to thank you very much for your patience tonight, and thanks for coming. And we will start our panel discussion in just a couple of minutes. Thank you.
Doug, thank you. That was exquisitely clear, crystal clear, and beautifully structured. As I alluded earlier, and Doug mentioned again, we'll now ask him to come and sit, I think, on the middle seat at the front. And meanwhile, let me welcome our two other panelists who'll join us. Professor Robyn Gallagher, here from the Charles Perkins Centre, Professor of Nursing at the University of Sydney, a recruit to the Charles Perkins Centre and the Sydney Nursing School some little while ago now, and Robyn is an expert in the secondary prevention of cardiovascular disease, working with patients who have cardiovascular disease to try and prevent them going into remission. So Robyn, as you'll hear, is working with the intransigent population, people like me and all of us who need to change our behaviour, probably know what we should be doing, but is never as easy to achieve as we might hope. And we need people like Robyn to help us to do that. So welcome to Robyn, and welcome to Professor Luigi Fontana, whom you've heard mentioned several times. Luigi is one of our Picasso professors here at the Charles Perkins Centre and in the Faculty of Medicine and Health. He is the Professor of Translational Metabolic Health and a world expert in caloric restriction, intermittent fasting. So welcome all, come and sit down. So the aim of this next sort of 20 minutes or thereabouts was to continue the discussion amongst an eminent group of relevant experts. And let me kick off by picking up, obviously, you mentioned the role of diet. That's something that's of particular interest to me, Doug, as well as to Luigi. And you gave a tantalizing insight into the evidence around intermittent fasting, or the lack thereof. And I wondered whether you might pick up on that point, and we'll hand it over to the other panelists.
Yes, so we've performed one study, and I am going to turn this over to Luigi, but it was on time-restricted feeding. And we did not find any benefit of time-restricted feeding. That was eating within an 8-hour period every day, improving cardiovascular health in midlife and older adults. We did see a small improvement in glucose function, in controlling blood glucose, and a small improvement in endurance capacity. But in terms of the cardiovascular health parameters that we talked about tonight, we didn't see any change in that. Now, these were healthy midlife older adults. So I think another follow-up study is required in people that aren't quite as healthy to begin that type of strategy. But really, whose advice I want to hear is Professor Fontana's, because he is the world expert.
Hi. Yeah, so our data, we have some data from a randomized clinical trial that we are trying to publish, and we are finding the same results than you in middle-aged, relatively healthy people. Intermittent fasting, so in our study, people, they were fasting 2 or 3 times a week, depending on their baseline BMI. If their BMI was between 24 and 28, they were eating only raw or cooked vegetables ad libitum twice a week, or if the BMI was between 28 and 35, 3 times a week. On the remaining day, they could eat whatever they want. So we achieved an 8% weight loss in 6 months, 16% reduction in body fat, similar to what we achieve with classical calorie restriction every day. We got a beautiful reduction in leptin, increase in adiponectin, no change in inflammation whatsoever. So we measure C-reactive protein, TNF-alpha, interleukin-6, all the cytokines and chemokines, and a tiny improvement in glucose tolerance and insulin sensitivity, unlike what we know with exercise and classical calorie restriction, where you have major improvement in insulin sensitivity, glucose tolerance, inflammation, blood pressure, and so on and so forth. So the data from my studies and other studies I've heard is that achieving weight loss with intermittent fasting without changing the quality of the diet during the non-fasting days has doesn't result. Again, there are people who are selling books before there are data, and they are very successful, but we don't data. And our data are consistent instead of with what also Steve is suggesting, that the quality of diet is super important. So your presentation is beautiful because it suggests that is a puzzle of factors. Of course, when we do science, we are forced to dissect and study one intervention at a time. But in reality, in the real life, we should combine the best interventions according to our genetics, to our lifestyle, to our work-related whatever, to achieve the results. But definitely this shortcut of intermittent fasting, I think it's far from being as powerful as exercise or dietary restriction and changes in quality. Maybe Steve can say something about it.
I guess potentially because you're undoing the good that you're doing during the periods of restriction by not changing the quality of the diet in those other days. I'm really intrigued by this idea of how small an intervention do you need? The breathing training was one example. Manos Stamatakis here is a world expert in physical activity, and their recent work is demonstrating really small, specific sorts of physical activity can yield tremendous benefits in terms of all-cause mortality or cardiovascular risk. But even more interestingly, if you can combine that with other small interventions in other realms, reducing your sodium a bit, doing this small amount of physical activity of a particular type, improving the quality of your diet just moderately, doing a little bit of fasting, that combination will synergize, do you think, Doug? Or is it additive, or we just don't know?
We don't know. And this is a bit of a sobering part of a response, but one of the reasons that we don't know is that national research foundations and organizations and the people that review for them really don't find that type of science to be compelling enough to support. So I get asked this question all the time: what about if you combine sodium restriction with exercise, as you just mentioned? And the answer almost always is that we don't know, because these trials are very expensive. They're at least hundreds of thousands of dollars just to perform a small pilot trial. If you do a full clinical trial, it's millions of dollars. And reviewers, and I do understand that, I've been a reviewer many times myself, they're looking at some novel, innovative grant application, and then you're asking to determine whether these 3 healthy lifestyle behaviors have an additive or synergistic effect. And they're only funding 1 out of every 10 grants. So that's another big part of it. And they have to choose. And so I think it's very difficult to do those studies because it's difficult to find the grant support to do that. But the main answer from my point of view is we don't know.
Yeah.
And it's because of that.
Yeah. And Robyn, if we're working with real patients in the real world, I guess we can, providing we're delivering safe care and intervention, we can try some of these questions, because clearly the evidence would support putting things together in simple measure so that people are better likely to adhere, as you were saying, Doug.
I think Luigi put it correctly in saying it's a puzzle of factors put together. So a person builds up a lifestyle that they value and they get a lot of support and fun and satisfaction about in their own lifestyle. They have a heart attack and they're quite anxious oftentimes and they're highly motivated to change. But the change process is complex, quite complex. For instance, changing sodium seems simple, but actually there's a whole manner of things that have to be changed, including whether or not you cook your own meals.
Right.
And the same applies. Intermittent fasting seems like a nice measure, but if a person is taking medications and they have to weigh up what time they take their diabetic medications versus is this a fasting day or not, it's quite complex. And I find that many studies are not done in translation research, is not done in people who are sick or balancing lifestyle. It even comes to exercise, but exercise is simpler. High intensity interval training done in short bursts is quite effective in people who are quite sick, including heart failure. So there's some good evidence there.
You mentioned drugs. Doug, you didn't mention drugs. That's interesting. How do you see the role of pharmacotherapies?
Well, you know, I guess you have to set the context of the question. If we're talking about promoting healthy cardiovascular aging throughout a lifetime, then I'm not really thinking about pharmaceuticals, prescription drugs, as much as I'm thinking about either natural compounds or these healthy lifestyle factors. But there is a movement within the field of biomedical aging research to determine if some of the drugs that have been shown to be very safe to reduce cardiovascular disease risk or to prevent a cardiovascular event in someone who already has cardiovascular disease, there is a movement to try to determine if those can be repurposed as safe anti-aging drugs that might have a broad effect in reducing all types of cardiovascular disease risk, sort of like statins have effects that go beyond just reducing cholesterol. But yeah, I think that we're very early in that, in testing those hypotheses related to repurposing of safe pharmaceuticals. Perhaps these folks have other.
Well, you know, the problem, you know, that aging starts in utero well before. Therefore, you know, the idea of prescribing a number of drugs, even if they worked in delaying aging and we don't have data, you know, the drugs are acting on particular pathways. So they are reducing cholesterol, they are reducing blood pressure, glucose, but we don't have drugs, you know, that are preventing cancer. So there is nothing, you know, we can give people, you know, to reduce the risk of cancer. Instead of some of these lifestyle are super powerful in preventing, in reducing the risk of malignancies. Again, because aging doesn't start, you know, when you are 50, 55, or 60, but it starts, you know, when in utero. So these lifestyles are definitely the only way, you know, to change this trajectory that you were showing. That, you know, basically there is an aging population, there is an epidemic of unhealthy aging that is going to make the system unsustainable. So if you are unlucky and despite everything you develop disease, you want to have the best medication. And so I think, you know, what we achieved over the last 50, 70 years in terms of improving medical care is fantastic. Nobody's denying that. But if we look at the future, if we look at the trajectory of aging of the population, unhealthy aging of the population, as you said, this is unsustainable. We know that in New South Wales, the government says, by 2050, the entire budget of New South Wales is going to be for healthcare unless we change our model. And that's what we are trying to do here at the Charles Perkins Center, to use the best evidence, combine it in some way, as you were showing, different interventions to come up, with new strategies and most importantly, new educational activities, because unless we start from schools, from primary school and secondary, university, the next generations of politicians, professors, journalists, engineers, economists, they're coming out of here. So if we teach them, how powerful are these interventions in preventing cardiovascular aging, dementia, cancer, because many of these chronic diseases we see in our hospital, they have a common metabolic substrate. By acting on these common metabolic substrates, we are preventing multiple diseases at once, and that's the strength of what we can do and what we can achieve that is going to make this world and especially the healthcare system sustainable. Otherwise, we're going to go where wealthy people who can afford very expensive healthcare, and the rest is going to be.
And I think,
left.
Robyn, you picked up on that point, the issue of comorbidities.
Yeah, but I was just thinking, given the amount of cardiovascular disease, even in this room, for people over 50, there is a argument you could postulate, let's put statins in the water, like we do with fluoride. But of course, that's the extreme end of things, isn't it? So for the patients that I see who've already got cardiovascular disease, the very best thing they can do is take their medications as prescribed so that they have an accurate prescription and so that it can be judged, the effects. But even with medications, again, there's problems with adherence and lifestyle change and perceptions. Even we did a study of 5,500 nurses, and even those nurses in New South Wales had doubts about continuing to take their medication because the perception that it's always better to not take medication somehow.
And just one other thing before we move on. A problem with taking, pharmaceuticals, prescription drugs, in terms of healthy aging, you have to think about what you're saying. You could ask someone to start exercising and promote exercise and healthy lifestyle behaviors, as Luigi mentioned, in elementary school or secondary school. But are you ready to put an 18-year-old or a 25-year-old on a prescription, of a pharmaceutical for the rest of their lives?
Precisely.
That's really a major barrier, I think, to this whole concept. Well, we're going to repurpose these drugs and we're going to use them to promote healthy aging. When are you going to put people on there? Because if you wait till they're 55 or 60, then we've already created, the basis for disease, and you can't start earlier. So that's one of the problems.
And it takes the onus off the rest of society for providing a healthy environment, a healthy food system, a healthy physical environment. It is another way of putting the onus back on individuals, and that's exactly what we needn't be doing, shouldn't be doing.
I know for myself, for people who've survived a heart attack, we ask them to exercise. So they have an exercise prescription, which is, in fact, maybe should be every time you visit your physician. But then if you're asking a 58-year-old woman to exercise in an environment where she doesn't feel safe, where she feels too far away from help should she get chest pain, then it's really quite difficult. But I'm interested in your discussion about heat immersion, because I was thinking where my brother lives, he heat immerses every summer because it's 45 degrees centigrade when he steps out the door. So I'm wondering how much cultural aspect is, given the studies were done in Finland, and I believe in your lab it would be Boulder. Yeah,
I mean, there's very limited data in terms of how generalizable the results are. But the thing to remember is it's not just being exposed to heat,
Yeah.
which we all are if we live in most climates, but it's getting your body temperature up and holding it there for 30 or 45 or 60 minutes. That is thought to be, and I emphasize thought to be, the stimulus. So we might go out and it might be oppressively hot, but then we get in the car and turn our air conditioning on, or we get to the office and we're in an air-conditioned building. So simply being exposed to heat. Now, if you worked hard enough out in the heat to raise your body temperature between that 1 and 1.5 centigrade, that might have an effect. And so these are the questions for the future. Can we safely do this just by sitting in a bathtub? Talking about translating this to the community. Not everybody in the community has hot tubs or access to it. So eventually, are we going to have to be able to prove this with just regular bathtub bathing at home? So these are some of the challenges to be able to say anything with certainty.
Yeah, because there are patients, despite 2 or 3 medications, they are not able to lower the blood pressure consistently. So, these tools could be some extra instruments, tools that, clinician, especially if we are, proving in solid randomized clinical trial that they work, I think, there are extra tools, that people and doctors can use, to control a number of people that are resistant to multiple drugs, antihypertensive drugs. But what is fascinating to me is how fantastic is human physiology. I mean, why this, respiratory training is triggering, this amazing response in terms of blood pressure and endothelial function. It's amazing. It's really amazing from a scientific point of view.
Yeah.
It's super interesting.
It's well tolerated, so
Yes.
people are willing to do.
The inspiratory muscle strength training averages about 95% in all of those 5 pilot studies, smaller trials that I put up on the screen, about 95% adherence. So if you assign them, in this case, if you put all those studies together, it would be hundreds, thousands of days of prescribed exercise. 95% of those sessions were performed, and we document that with instrumentation. So whether it's the short exercise or the type of exercise, they can do it at home. They can take that device on the road with them when they travel. We don't know, but the adherence is very high, and the same thing with the heat tolerance.
I think it'd be very interesting to move that particular inspiratory effort, exercise, into a population already diagnosed with the disease, because you can see how they could do it.
Yeah.
And it would be readily fitted into, for instance, a cardiac rehab program, or I think it might make sense to people, and I think sometimes we can educate as much as we like, but if it doesn't make sense to someone that how things work in their own ideas, they won't do it.
Yeah.
And that's the key, isn't it? Individuals like doing certain things and not other things, and there are things that make sense and are enjoyable, and there are many different ways of achieving a given outcome, whether that be in physical activity or diet or what have you, without taking away the pleasure or making it onerous. And that's the trick, isn't it? It's.
I hesitate to say, but some of the reason people enjoy cigarettes is because they enjoy the mouthfeel of the air going over the back of their throat. They find it quite soothing, and it's one of the things they give up. So if we could give them a replacement, which is so healthy, perhaps.
We're heading into dangerous territory here, I think, Robyn. Yeah.
Goodness
You do your
sorry
inspiratory
for the
training
drift.
But still, it shows how basically it's cultural, because, you know, 40, 50 years ago, everybody was smoking. It was basically, especially men, everybody. Right now, if you go in US, smoking is really almost unacceptable. You feel really bad if you smoke. So I think, it shows how, you can change in 20, 30 years, you can change, the perception of what is good and what is bad, if you have a consistent information. The problem is that we don't have a consistent information. We have a lot of disinformation. That's the problem.
And I
So we
think
could have people out there using this in public and going, well, this is an important part of my health.
Yes, that's an interesting thought. It becomes then fashionable. Wow. The designer inspiration device. Yeah. Well, look, I think we've come to the end of our discussion, fascinating as it is, and I think I might leave it, Doug, to you for a final comment. If you were to recommend to those of us in the room before we go and inspire some a glass of something outside, perhaps not inspire it, but just imbibe it would be better. What would you recommend?
I think, as I mentioned, I think exercise and dietary influences are the most powerful, but one point that I want to make, maybe it's a good way to wrap this up, is that the reason why I talked about all those different types of strategies is really based on what you just said, is that we're all wired differently. We all have different interests, and we find one strategy to be pleasurable or tolerable and another not to be. And I think it's important to try to establish as many evidence-based strategies, whether it's lifestyle strategies or natural compounds, whatever it is, so that the person out there who, for whatever reason, just finds exercise very difficult to perform has options, and those options are evidence-based, that you can have confidence in those options. And I think that's part of our responsibility as biomedical sciences, to create options for that physician, in the photograph that was saying, what else do you have? That's how our laboratory is really operated, under that premise that we need to provide the clinicians and the public options, but options they can have confidence in. So,
totally agree, and that's very much what we're trying to do here as well. And I think I'd pick up a final point, which comes back to your observations around funding, Doug, and that is that these are also evidence-based, mechanistically founded. So we understand the basic biology of these processes, and that allows you to take them into evidence-based trials in a way where you can claim, in the same way as somebody who's developed a new drug knows the pathways upon which this is acting, we can say the same thing. And in that way you have a really hard science which will help Robyn ultimately with your patients, and I think all of us go from birth to old age as healthily as we can. So thank you, Doug. Thank you, Luigi and Robyn. Thank you, everybody, for being with us.